Question 1. The value of I in the diagram below is 90 degrees, 180 degrees, 200 degrees, or 240 degrees. So the rule here is that adjacent angles that make up one revolution add up to 360 degrees. So I and 120 should add up to 360 degrees, so we can work backwards to find out the value of I there. Now if we take 120 degrees away from 360 degrees, you can see in the diagram that A makes up the rest of that revolution. So 360 minus 120 is 240. So our final answer there is D, 240 degrees. Question 2. Find the median of 5, 6, 7, 9, 11, and 12. The median for an even number of values, and we have 6 values here, the median for an even number of values is the average of the two middle values once the data is placed in order. Now the data is in order conveniently in this question. Can you see the two middle terms there? If we split that set of 6 items in half, we'd have a line between the 7 and the 9. So the two middle values are either side of that split. So the 7 and the 9 are where we look to find our median, and it's about taking the average of those two. Now the average of some numbers is add them up and divide by how many there are. So the median can be found by doing 7 plus 9, we add the two middle values together and we divide it by 2. So we get 16 on the top, divided by 2, and our final answer is a median of 8. Question 3. 7.659 divided by 1,000. We move the decimal point one place to the left for each 0. That's when we divide by 10 or 100 or 1,000, things like that. Move the decimal point one place to the left for each 0. Now we have 3 zeros there. If we had 1 0, we'd move the decimal point one place to the left. If we had dividing by 100, we would have 2 zeros and we'd move the decimal point 2 places to the left. Here we're dividing by 1,000, we have 3 zeros. So that's why we're moving the decimal point 3 places to the left. So if we write that out carefully there, we've got 7.659 at the moment, and we're moving that decimal point 3 places to the left. And we'll have to be careful about this. You'll notice when we skip 3 places to the left, there's 2 places there that don't seem to have numbers. We're going to fill them in with zeros. And when the decimal point becomes at the left-hand end of my arrows there, I need to put a 0 at the very front just to make sure it's clear to everybody that this is a decimal number that we have. So What we've done there is moved the decimal point 3 places to the left and done some filling in with zeros to make it look like a proper decimal. So our final answer there is 0.007659. Question 4. Solve y over 3 minus y over 2 equals 7. Okay, for these types of fractional equations, I like to do this sort of method. Multiply every term by a magic number, and that magic number needs to have 3 and 2 both being able to divide into it. So we're going to multiply every term by 6. How did I get the 6? Well, 3 times 2 is 6, and by creating that 6 by multiplying my two numbers together, I can be assured that those two numbers both go into my magic number. So let's see how that works. Write out those terms, each in their own brackets there, just to be clear, and it's good if you write these out quite large. So we're going to multiply 6 by every term, including that last term. And then we're going to say 3 goes into itself once, and into the 6 twice. On the second term there, we're going to say 2 goes into the bottom once, and into the 6 3 times. Now when we get a 2 and a 3 as the outcomes from that cancelling down there, that 2 in the first term can multiply by the top, the y. And so we'll get 2y. In the second term there, we've got a minus number to begin with, remember. And when the 2 went into the 6 3 times, that 3 multiplies with whatever's on the top of that fraction. In this case, it's a y. So we'll make sure we'll write down the minus and the 3y as a result of that cancelling. Now on the right-hand side, there's no fraction as such. There's nothing on the bottom there, or there's a 1 really, invisible. But that means we can just go 6 times 7 makes 42 on the right-hand side. There's no cancelling down needed in that bit. Okay, let's simplify the left-hand side. We've got 2y minus 3y. We're taking away one more than we've got there. So we end up with a minus term there of minus y, or minus 1y really. But we don't have to write the 1 in. So minus y equals 42. And when there's a minus on one side of an equation like that, we can switch it to the other side. Effectively what we're doing is multiplying or dividing by minus 1 on each side, but effectively you can just switch sides with the negative sign there. So y equals minus 42. Question 5. 17 over 20. A fraction of 17/20ths of a room is painted. What fraction is left unpainted? Is it 3 over 20, 3 over 10, 17 over 5, or 7/10? Okay, a whole room, if we divided that into 20 areas, it can be written as a fraction as 20 over 20. Now, a fraction with numbers over itself there, 20 over 20 is effectively 1, and we're considering that to be one whole room. We're just breaking it up conveniently into 20 places. So if we subtracted the 17/20ths of the room that's painted, we'll be able to figure out what fraction is left unpainted. So it's a subtracting fractions type question here. But the trick was to express the room as 20 over 20, a whole room as 20 over 20 in this case. It helps us figure this out. So we subtract across the top and we get 3, and we keep the bottoms the same when we subtract fractions here, and we get 3/20ths. So I think you can see that 3/20ths of the room is left unpainted. Question 6. Simplify, writing your answer as a whole number, 4/7 all to the power of 0. If any item has a power of 0, it equals 1. So this 4/7 is all to the power of 0, so that whole thing ends up equaling 1. Question 7. Find the volume of this prism. We've got an area of 19 centimeters squared and a prism height of 30 centimeters. Now our steps for formula solutions, if we've got a formula, and we do for this one, we'll write our formula on line 1, we'll substitute all the numbers in on line 2, then we'll do our calculating of the answer on the next line, and at the end we need to remember to check our units to see if they're correct. Alrighty, so the volume of a prism, when we're given the area of the cross section, that blue section there, we're given that in the question, we multiply by the height to find the volume. Now we have to be careful here. Height in a prism isn't necessarily from the ground up, it's sometimes how far back the cross-sectional shape goes. You can see that that blue triangle, if it was to move to the left, there's a triangle of exactly the same size on the other end of that shape. So we consider that 30 centimeters, even though it's a bit horizontal or a bit diagonal there, we consider that 30 centimeters to be the height of the prism. So we're going to multiply the area that we're given by the height that we're given to find our volume. So area times height is our formula. We'll write that, we've effectively written that on our first line there. Now we're substituting our numbers in. The area given in the question was 19 times the 30, which was the height given in the question. And we get a final answer of a volume of 570 cubic centimeters. So for area we've got square centimeters, and volume we need cubic units, so it's going to be centimeters cubed. Question 8. Increase 60 by 10%. We find the percentage amount. 10% can be written as 10 over 100 times by 60 gives us 6. So 6 is 10% of 60. And the question says to increase 60 by that amount. So we'll add the 6 to the original. 60 plus 6 is 66. So 66 is 60 increased by 10%. Question 9. Find the height of the building below if it meets the ground at 90 degrees. Okay, Mr. Pythagoras would say for this diagram that h squared equals 60 squared minus 48 squared. The reason we have a minus in that version of Pythagoras there is that we're finding one of the shorter sides of the triangle, the right angle triangle. If we were finding the hypotenuse, we'd have a plus in between those two squared numbers. Alright, to work that out, we've got h squared. 60 squared is 3,600, trust me, and minus 48 squared, which is 2,304. You can check me on your calculator there. And we'll join those two numbers on the right hand side there to make h squared equals 1296. Then to work backwards to find out the height, just the h bit instead of h squared, we're going to have to do the opposite of squaring, which is square rooting both sides. On the left hand side, a square and a square root will cancel out, leaving us just with h. And then in our calculator we'll just try to find the square root of 1296, which is 36 meters. We're working in meters, so we check our units there. Question 10. Factorise 2n squared minus 14n. We find the largest term that is common to both terms. We put this out the front of the brackets. So if we stare at those two terms there, what can go into each? There's a 2 that can go into each, and there's an n that can go into each. So we'll stick that out the front of the brackets. That's the first part of factorising. Then we'll say to ourselves, how do we fill in the brackets with appropriate terms from there? So we ask ourselves, for that first space in the brackets, what have we got to multiply 2n by to get 2n squared? Well, we'll need another n. Then for the second part of the brackets to fill in there, we ask ourselves, what have we got to multiply 2n by to make minus 14n? So we'll need a minus. We'll need something to multiply the 2 by to make 14. So I think we'll need a 7. And so I think minus 7 might be the go. So we should always check our answer for factorising by expanding and seeing if we get back to the original question. So if I expanded my answer there, my right hand side, would I get back to the question? So 2n times n for the first part, yes, that makes 2n squared. And for the second part, 2n times minus 7, that would make minus 14n. So that successfully gets us back to the original question. So in factorising questions, you can kind of tell if you're on the right track or not. The other thing to check is to see if there's anything still common between the numbers that are inside the bracket. If there is something still common there in that section, you haven't taken out something big enough for your front number. But that's for another day. So final answer, 2n outside of n minus 7.